Welcome once again to the lecture in physics. Our today's topic is objective type questions in previous exam, and of course the topic for the respective examination is surface tension. We are going to take actually 3 problems, but before that we must have to begin with these 2 problems. If you were observe my previous lecture, which is based on the surface tension, how to solve the problems based on surface tension, then and only then it is possible for you to easily understood these problems. Okay, without wasting time, I am solving the first one. A big water drop is formed by combination of n small droplets of equal size. There is a big water drop. Just I have to draw a big water drop somewhere here with a big one. It is formed, actually it is prepared, it is produced by combination of n small droplets. There are small droplets here. I can show that droplets like this. They are having equal size, means their radius is same. If one of the radius of single droplet is smaller, that corresponds to the all droplets. And the number of these droplets, as I shown here, 6, but there are actually their number is n droplets. And they are combined together. They get together, coalesce together, and they form a single drop. I have to imagine the radius of big drop as capital R. Okay. What the actual requirement? The ratio of surface energy of n droplets to the surface energy of big single drop. We know very well that according to surface tension, every these droplets possess its surface energy. That surface energy E1 for the n droplets, we have to find out that value, and the surface energy of the single drop, which is already produced from these droplets, is E2. We have to obtain this expression as well. And what they ask the ratio of surface energy of n droplets. Surface energy of n droplets is E1, that of surface energy of the single drop is E2. And the requirement is E1 upon E2. This is what they have asked to us. Okay. So according to the expression for work done during formation of a drop is nothing but a W is equal to T into dA. And you must have to know that this dA is change in area if you are trying to find out the work done, or this is the area simply for the respective drop. And the same is the expression for amount of energy, E equal to T into dA. Just I would like to repeat here. dA is, if you are taking area of the drop, then either it is area of single drop or area of all these droplets while finding the energies of these respective positions. Okay. So let me begin with the E1 as the energy of all these n droplets. How that can be obtained? Again, T as per that expression, T into dA. dA means area of each droplets multiplied by of all area number of droplets. Means here area of each droplet is 4 pi small r square, as it is a spherical in shape. This is the area of single drop, and as there are n droplets, it should be how to multiply by n. So this is the value of E1, energy of surface energy of all these n droplets. What's about the surface energy of single drop? Same expression you should have to take. T into dA. dA means area of the single drop. It is 4 pi. Now it is capital R square. Let me begin with the expression for E1 upon E2, and we can find E1 upon E2 from this as E1 upon E2 is equal to T into 4 pi R square n upon E2 means T into 4 pi capital R square. Here T get cancelled, 4 pi get cancelled. Now the remaining terms are simply R square into n upon capital R square. Now you have to find out the relation between this R square upon capital R square. How that can be determined? Of course, with the help of taking their volume as equal. V1 equal to V2 means volume of single drop V2 is equal to volume of all these n droplets. Volume of single droplet is 4 by 3 pi r cube. And as there are n droplets, it should be multiplied by n. This is the volume of all these droplets, which is the total volume V1 equal to V2. Now, the volume of single drop 4 by 3 pi capital R cube. Here 4 by 3 get cancel, pi get cancel, R cube n is equal to capital R cube. What's about R simply? R n raised to 1/3. I'm taking cube root of on both sides equal to capital R. Now as there is R square upon capital R square, therefore E1 upon E2 can be determined in this way. R square as it is, I am taking that value, n upon now capital R square is R square n raised to 2 by 3 capital R square. I am taking square of all these terms. Therefore capital R square is this, R square n raised to 2 by 3. Here R square get cancelled. N raised to 1 upon n raised to 2 by 3 means n raised to 1 minus 2 by 3. E1 upon E2 is equal to n raised to 1. I am going to shift this n raised to 2 by 3 to the numerator. It becomes n raised to minus 2 by 3. The total value is n raised to 1 minus 2 by 3, and it comes out to be 3 minus 2 is 1, n raised to 1/3 means cube root of 3, and it is E1 upon E2 means cube root of 3 upon 1. And the option which we are going through is the last one. This is the correct option, cube root of n. Sorry, I made a mistake here. It should be n there because it is n raised to 1/3. Cube root of n upon 1. This is the final correct answer of that question. So this is how you can solve the first problem.